All right, guys, let's see if we can get through a few more examples in our next 15 minutes together. I really don't want to make these longer than they need to be, but I know that there is some really important information that you need to hear spoken as well as see written in your book. So 2.5 objective 3 is solve polynomial equations. I want you to remember what the objective was for objective 2. It was find the zeros. So what's the difference between solving and finding the zeros? There isn't a difference, really. A solve problem, notice there's only x and then there is no f of x or y. We find zeros of a function. We solve an equation. An equation only has this x in it, okay? And we know it needs to equal 0. So we're going to go through the same steps here with example 5 as we did in example 3, okay? First step being, let's find all the possible rational zeros, okay? So remember, the p would be the factors of the 24. And the q would be the factors of the 1. So again, we have an example where we have multiple factors for 24, 1, 2, 3, 4, 6, 8, 12, and 24. And yes, you have to list them all. And only one factor for q, and that would be 1. So it's 1 over 1, and 2 over 1, and 3 over 1, and 4 over 1, and 6 over 1. You get the point. Okay, remember, if q had more than one factor, you would have to go back and write the list again. What over the new factor of q, okay, so it wouldn't all just be over 1. But what's good is most of the time you'll have repeats that you can cancel out. So having an extra factor for q does not mean doubling your list completely. Okay, so let's start testing. This time I'm going to use a graph to help narrow further, okay? This is not cheating unless you've been told to not use the graph, or unless a direction would say no graphing calculators allowed, which is true, okay? I'm just trying to narrow our amount of time. So when I look at a graph here, let me scoot it this way. When I look at the graph of x to the 4th minus 6x squared minus 8x plus 24 equals 0, okay, I can see that it has a root, a 0, where x is 2. So out of this big list of like 16 possible options, 8 positive, 8 negative, I'm going to try positive 2, okay? So let's see what we get there. Okay, if the 0 is rational, the only possibility is going to be x equals 2. We know that from the graph, and it was one of those listed. The others just aren't panning out. All right, so we're going to test it to be sure, and I'm really sorry if my head gets in the way here in a second. Let me try to scroll down to prevent that. Okay, so we have the 1. Notice the 0 here. This was one reason I wanted to do this one in particular, was because this function was missing a term. See how it missed the cube term? It's like it went from the 4th stair to the 2nd stair, and then to the 1st stair, and then to the floor. So it skipped that 3rd stair. We cannot skip the 3rd stair when we set up our synthetic division. So 1, 0, negative 6, negative 8, negative 24. When we go through with the 2, remember, if the 2 is really a factor, we should get a remainder of 0. And we do. Okay, remember that this now is our depressed polynomial, x cubed, because it steps down 1 degree from what we started with. 1x to the 4th became 1x cubed, plus 2x squared minus 2x minus 12 equals 0. Okay, now, I have a little note over here. Think back to multiplicity from lesson 3. What would you say the multiplicity of this 0 is? Okay, remember the behavior. Let's see if I can do this with the mouse. Yes. All right, the behavior of our graph at the 0 tells us the multiplicity. You see how if you just focus on this point, you can see a little parabola? That tells you what you need to know about your multiplicity. The multiplicity is even. What that means is that 2 is at least a double root. Okay? So what we can actually do is divide by the 2 again. And I guess we're going to do that here in just a second. First thing I did was I wrote the x equals 2, 0 as an x minus 2 factor. Here, the 1, 2, negative 2, negative 12, that comes in here as our depressed polynomial. All right, so because x equals 2 has a multiplicity of 2, we can divide by x minus 2 again. That does us a favor that we don't have to go back through and do p over q with this blue polynomial. We could, but we don't have to if you recognize the multiplicity. Okay, so we are going to go on ahead and we're going to divide by x minus 2 again. All right, so here was the factored form I showed you on the other page. If we divide the depressed polynomial by x minus 2, okay, or by the 0, which is x equals 2, we get another remainder of 0. Yes, that says what we thought about the multiplicity was correct, okay? Now we have x minus 2 squared, okay? The reason I have that squared is because we actually divided by that factor twice. So that factor shows up twice, and then x plus 4 times, or x squared plus 4x plus 6 is in there one time because that's what we have right here, okay? Now we're going to go through and we're going to solve from there. So the x minus 2 is no big deal. You just say x minus 2 equals 0 or x equals 2. That has a multiplicity of 2, but we just have to list it one time in our answers. This one, unfortunately, we can't factor x squared plus 4x minus 6. So we've got to go the quadratic formula route. Okay? Here's quadratic formula. I filled it in with the ABC, and then you're going to go through your order of operations, and you're going to get to negative 4 plus minus 2, square root negative 20. Okay, so here's a giveaway about part of the reason why we could not factor, because we are getting imaginary roots. Okay, so remember, you got to be fluent with simplifying the square root of a negative number. That'll be 2i radical 5. And then divide the negative 4 by the 2 and the 2i radical 5 by the 2. Okay, so we have 3 unique roots: 2, negative 2 plus I radical 5, and negative 2 minus I radical 5. Let's look and see what happens on the graph to tell us that may have been the case. Okay, so on the graph, okay, we have a quartic. That means even degree, up, up, because it's quartic positive. We have this double root at 2. That counts for 2 out of the 4 zeros. Okay? The other 2, we can tell they happen over in here because you have this funny behavior there. We have this odd behavior going on right there. Okay? If you check the value of negative 2 plus radical 5, I think you're going to find that that happens somewhere around this x value. That would go with that, okay? But we have 2 real roots, really 1 real double root, and then 2 imaginary roots right there, okay? Imaginary roots always come in pairs, okay? They always come in pairs. So where you have a negative 2 plus I radical 5, you always have a negative 2 minus I radical 5. Okay, let's go on. Example 6. Use the linear factorization theorem. So that's at least the third theorem I mentioned to you in 2.5. 2 in the previous, okay, 3 in the previous. and then the fourth here. We had rational zero theorem, remainder theorem, factor theorem. Now I'm saying linear factorization theorem. We have a whole lot of theorems, and you need to be writing these down in some way to study them. Folded sheet of paper, note card, whatever. Maybe we'll do that in class tomorrow. Okay, so finding a polynomial with given zeros. We did this with quadratics back in Algebra 2. Now we're going to do it with things beyond quadratics, just larger polynomials here. So we are supposed to, we're given a couple of rules here with example 6. It says make sure it's a fourth degree, and it has to have at least these three zeros, -2, 2, and I. Okay, that was given in the problem. Now, there's also something that was implied. Okay, if I remember what I just said a few minutes ago about -2 plus I radical 5 and -2 minus I radical 5, if I is a 0, then -I is also implied as a 0. Okay, so you have to throw this one in there yourself because you know of something about complex conjugates. Another thing we should probably add to our study list. Okay. So what we're going to do is we're going to work backwards like we did last year with quadratics. We're going to start with the zeros. X equals -2, x equals +2, x equals I, and x equals -I. We're going to change those zeros into roots. Remember, roots is where we take these zeros and I'm sorry, I didn't mean roots, I meant factors. We take these zeros, these roots, and we make them equal 0. Okay, and I even wrote roots. Okay, that should say factor right there. Not roots, but factor right there. Okay. All right, then what we do is we take these individual factors and we write them in as a factored equation. Okay, so x plus 2 times x minus 2 times x minus I times x plus I is going to give us 0. I've underlined because we're going to have to expand this. And when we do, we can only multiply two things at a time. And I like these because these will produce a difference of squares. That's friendly to us this time. It won't always be this way. And these will produce a difference of squares. Okay, your complex conjugates will always produce that difference of squares. Okay, so x plus 2 times x minus 2 gives us x squared minus 4. And x minus I times x plus I gives us x squared minus I squared. Remember, you could FOIL the x plus 2 and x minus 2 and the x minus I and x plus I. But your OI is going to cancel out every single time. All right, so let's keep going. Hope some of you are recognizing this I squared. Okay, recognize this I squared. I squared is -1. So you have to change that. Okay, and that's what I've done in this step. X squared minus I squared is really x squared plus 1. Okay, and now to finish this, remember we're going backwards. We're trying to get the equation from the zeros. We multiply this out, and we have x to the 4th plus x squared minus 4x squared minus 4 equals 0, or x to the 4th minus 3x squared minus 4 equals 0. This is your answer. Okay, this right here. Maybe the book might say f of x equals. You might check me on that one. Okay. We have one more thing to cover, and unfortunately, I'm afraid I don't have enough time to do it on this video. It's not going to be another 15 minutes, I promise. It's not going to be on this video. So I'm going to pause this now and put my kids to bed, and then I'll do the very last part of 2.5. Very last thing you're going to be tested over.